Hello everyone, welcome to another lecture of the course Digital Signal Processing. Till now we have been looking at various operations on discrete time signals. We have seen various transforms that allow us to analyze the signals as well as systems in greater detail. So now in this lecture, let us try to go ahead and analyze something new. So for that, what we will consider is a small system with say impulse response h of n, and the purpose of this system be noise cancellation. So let x of n be the input and let y of n be its output, and let us assume that this x of n is my voice signal. So this is the sampled version, that is discrete version of my voice signal, and the output, that is y of n, is basically noise cancelled voice signal. And this noise cancellation system is installed in such a way that when I speak in this system, its output is to be generated in real time. That is, I speak or use some kind of microphone for speaking here, and that microphone has some kind of this system attached to it, and in real time it provides me with noise cancelled voice signal. So basically I require some kind of real time operation. So I require real time noise cancellation. We know that this noise cancellation can be achieved by using some kind of high pass filter, and therefore we know that this filtering operation can be represented by the convolution operation, and therefore this y of n can be written as x of n convolved with the impulse response, that is h of n, which can be written as summation k running from minus infinity to infinity x of k h of n minus k. So this is the convolution operation that we use in order to obtain the filtered output. So this is the filtered output. Now when we use this system here, or this equation or convolution here, and observe this summation, so we can observe that all the values of this x of n or x of k are used, because this summation has a range from minus infinity to infinity. So basic assumption while using this convolution is that we are having the entire signal with us. So when we are using this equation, we have entire input signal that is x of n with us. But when we are claiming that we want a real-time system or real-time noise cancellation, entire x of n or entire sequence of the input won't be available with us. Therefore, in real time, entire input sequence won't be available. So how to go for this real-time noise cancellation? So what we can do is, we can wait for some small amount of samples of this x of n, perform filtering on it, save that, then wait for another block, again perform filtering, and then combine both the outputs or both the filtered outputs so that the resultant is the required filtered output of the combined signal that we are getting after two blocks. So what I mean to say here is, suppose this x of n is the entire signal which won't be available at the time of real time case. So what we can do is, we can wait for say m number of samples of this x of n, then perform filtering, and store it. Then again collect the next group of m samples, repeat the same thing, and store the value and combine the output for the first block, that is the one corresponding to first m samples, and the second block of the input signal, such that it gives us the DFT, it gives us the filtered output of the combined sequence. So for example, suppose the blocks that we get are x1 of n, x2 of n, and so on up to say xm of n, and each of this block is of length m. Then what we need to do is, we need to perform filtering, and we would get some kind of output here, that is y1 of n, y2 of n, and so on up to ym of n. And in order to obtain y of n, that is the final output here, this y of n, we need to combine all this y1 of n, y2 of n, and ym of n, that is filtered output for each blocks. So we need to obtain y of n using all these small filtered blocks. Now the normal intuition say that we can just have it as y1 of n, y2 of n, and so on ym of n, the same way in which we had considered this x of n. So we know that this x of n can be entirely represented by just appending all of them, that is x1 of n, x2 of n, and so on. So in the same sequence we can just combine these y1 of n, y2 of n, and ym of n in order to obtain this y of n. But now if we look at this convolution sum here, so we have some kind of dependency on previous and past values of this x of n, means all the values are to be considered in order to find the single point of this y of n, which means that just combining these or just appending these values will not be of any use to us. We need to have some kind of proper mechanism or proper methodology in order to obtain the proper y of n. So for that we have two kind of methods, that is overlap and add method and overlap and save method. So in order to perform real-time filtering, and obtain proper output following two methods can be used, or you can say are used. So the first one is overlap and add method, and second one is overlap and save method. So let us try to understand these methods one by one. So in this lecture we will first consider overlap and add method, and in the next lecture we will go for overlap and save method. So let's start with the overlap and add method. Now in this method what we consider is we have a filter h of n whose length is, so we consider h of n with length m, and what we do is we split this initial x of n, that is the entire signal, in the blocks of length m. So the first step that we do here is consider m length blocks of x of n, and then once we split the entire signal into small blocks, say x1 of n, x2 of n and x3 of n, then we perform the filtering operation. So let's say we have the ith block given as xi of n. So once we have this xi of n, we perform filtering, that is we find the value of yi of n, which is equal to xi of n convolved with the filter, that is h of n. And once we have this filtered output, then we need to combine all of these blocks filtered output. So if we observe this convolution sum here, we have some kind of overlapping as well as addition that is required to obtain the final output. So in this case what we do is we consider the m-1 points of the previous block and m-1 points, initial m-1 points of this current block, and just simply add them. So what we are basically doing is this filtering operation leads to 2m-1 points. In that the points here and here, that is initial points, initial m-1 points of second block and last m-1 points of first block are added. So suppose we have x of n here, which is convolved with h of n, and that results in y1 of n, and let's say my y1 of n has a sequence of y1 of 0, y1 of 1, and so on up to y1 of m, and so on up to y1 of 2m minus 1. Similarly, x2 of n convolved with h of n results in y1 of n, y2 of n, which can be given as y2 of 0, y2 of 1, and so on up to y2 of m minus 1, and so on up to y2 of 2m minus 2. So this should be here 2m minus 2, because this filtering operation would be giving us a sequence of 2m minus 1 length, so it would be from 0 to 2m minus 2. So what we will do is, we will consider the last m minus 1 points from this y1 of n and first m minus 1 points of this y2 of n and add them. So we would be simply overlapping them, overlapping this y1 of n and y2 of n, overlapping its m minus 1 points here and m minus 1 points here, and simply add them in order to get the final y of n. And we will do this for all the blocks that we are going to consider in the further process. So the last step in this is, the last step in this method is consider last m minus 1 points, or say values, of the sequence yi minus 1 of n and first m minus 1 values of yi of n. Then we need to overlap and add those values. To obtain final value of y of n. So let us try to understand it with a simple example in which x of n is given as 1, 2, 3, 3, 4, 5, and let's say h of n is given as 1, 1, 1. So now if we observe here, the value of m is equal to 3, which is length of filter, and if we consider the value of m minus 1, so it is equal to 3 minus 1, which is equal to 2. So basically we need to overlap two values. Now we had also seen that this x of n has to be split into the blocks of length m. So here the length of the signal is 6, so we just have to consider two blocks, that is 1, 2, 3, which would be the first block, and 3, 4, 5, which would be the second block. So this x of n can be split into two blocks. So the first block, say x1 of n, which would be 1, 2, 3, and the second block would be x2 of n, which would be again 3, 4, 5. And now we need to just perform convolution for both of them. So we need to perform y1 of n is equal to x1 of n convolved with h of n, which is equal to 1, 2, 3 being convolved with 1, 1, 1, and the value that we obtain is given as 1, 3, 6, 5 and 3. So this 1 and 1 start from 0. So we have this sequence here. Similarly, y2 of n can be obtained as x2 of n convolved with h of n, which comes out to be 3, 4, 5 being convolved with 1, 1, 1, which comes out to be 3, 7. Then the value that we have here is 12, 9 and 5. So what we have is y1 of n is equal to 1, 3, 6, 5, 3, and y2 of n is equal to 3, 7, 12, 9 and 5. So these are the values that we have obtained. Now if we observe the value of m minus 1, so that is equal to 2. So we have the value of m minus 1 as 2. So we need to combine the last two values of y1 of n and first two values of y2 of n and simply add them. So basically we need to combine these two values, that is we need to add these two values as well as add these two values, and when we do that, the final output that we obtain is from y1 of n the values 1, 3 and 6 remain as it is, whereas here we have 5 plus 3, then we have 3 plus 7, then we have 12, 9 and 5. So therefore the final output that we obtain is 1, 3, 6, 8, 10, 12, 9 and 5. So this is the output or the final y of n or the final filtered output that we obtain using the overlap and save method. Overlap and add method. So in this lecture we saw that when we need to perform real-time operations, then at that time the entire signal is not at all available with us initially. So therefore we need to perform filtering operation on small blocks, and we need to have some kind of mechanism such that the filtered output of each blocks is combined and we obtain the desired output. So we have two methods, that is overlap and add and overlap and save method. So here we considered overlap and add method, in which initially we need to split this x of n into small length blocks, that is m, where this m is the length of the filter, that is h of n. Then we need to perform filtering on each of this block, that is we need to perform the convolution operation and obtain yi of n, where this I is the block number, and each block or the length of each of this y of n would be 2m minus 1. And the last step is to combine the m minus 1 points of this yi minus 1 and m minus 1 points or initial m minus 1 points of this yi and add them in order to obtain the final output. We have also seen a small example to understand this entire concept in better way. In the next lecture, we will look at the second method, that is overlap and save method. Till then, let's stop here. Thank you.